today you are going to be using the quadratic formula, but before we can use the quadratic formula, we need to go over simplifying square roots. So we know the basic square roots, like the square root of 16 equals 4, square root of 49 equals 7, square root of 144 equals 12, square root of 81 equals 9. But what if the numbers aren't a perfect square, like the square root of 56, or the square root of 48, or the square root of a negative 32, or the square root of negative 24. Okay, these aren't going to be whole number answers, but we can simplify them further. So for example, we're going to do the square root of 56. So the first thing you want to do is make a factor tree to find all of the prime factors of 56. So remember, prime are numbers that can only be divided by itself and 1. So we're going to start off by breaking the 56 down to 7 times 8. 7 is prime, so we can't do anything else to it, but 8 can be simplified further into 2 and 4. And then the 4 can be simplified once again to 2 and 2. So now that we cannot simplify this any further, we're going to rewrite the 56 using these prime factors. So the 7, 2, 2, and 2. Okay, so from here, you want to find pairs. Okay, this pair will dissolve to form one number and go in front of the square root. And the reason this happens is, say we choose this pair. 2 times 2 is 4. The square root of 4 is just 2. So that 2 goes out in front. The 7 times 2 are both still inside the square root, but you still want to multiply them to simplify it. So your answer is 2 times the square root of 14. Okay, let's try another one. Square root of 48. So again, we're going to make the factor tree and keep breaking down the numbers until you get prime numbers. Okay, and then you write all of those prime factors inside the square root, and again you look for pairs. So we have a pair here, but we have another pair here. Okay, but you're still going to do the same thing. So each of those pairs is going to have one number come out. So we'll have 2's, and the only thing left inside the square root is a 3. And anytime you have more than one number that comes out of the square root, you need to multiply them together, and we'll get 4 square root of 3. Okay, negative square roots are pretty much the same thing. Do you guys remember when we went over complex numbers and I squared equaled negative 1? Well, if I squared equals negative 1, then I must equal the square root of negative 1. So basically, if you get I by itself, you'd have to do the opposite of squaring. So the square root of I squared would be I, and the square root of negative 1 would have negative 1. But anytime you have a negative inside the square root, you're going to have a complex number. So for example, the square root of negative 16 is 4i. Square root of negative 36 is 6i, and the square root of negative 121 is 11i. Okay, so we're going to use this to simplify some more square roots, like the square root of negative 24. So we're going to break it down just like we did the others. Write that inside the square root. Find a pair, bring that number out. That negative inside, we don't want that there. Anytime you have a negative there, you're going to make it positive and make the I come out. Okay, so that I is going to go right after the 2. Okay, so we have 2i square root of 6. Okay, so the reason why this is an imaginary number or complex number is because you can't take the square root of a negative number using the numbers that we know of. Okay, so we have the I. Okay, so what I want you to do is pause this video and complete part 1 of today's assignment. It's on my website, and part 1 is just simplifying square roots. So when you complete part 1, I want you to come back, watch the rest of the video so you know how to do part 2. Alright, welcome back. So can you solve this problem by factoring? Okay, so what we have been doing, where you find numbers that multiply to -3 and add to -3. Go ahead and try to do that. Are you having trouble? Hopefully you are. Okay, this problem cannot be solved by factoring. There aren't any numbers that will multiply to -3 as well as add to -3. This problem still can be solved. We can figure out what x is, but we have to do this another way. And that way is using the quadratic formula. So anytime we have a problem of this form and we can't factor it, we want to use this formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Which does look a little bit complicated. So we'll do a couple problems and make sure you understand it. Okay, so let's go ahead and do that problem that we couldn't factor. So first thing we want to do is identify a, b, and c, which is some stuff that we've done before. So a is 1, b will be -3, c is -3. So you're going to take those numbers and plug them into that formula. So hopefully you wrote that formula down. If not, make sure you go back to the next slide. Previous slide. Okay, so plug them in. That negative in front of the b has to be there, and then you plug in b, which also happens to be negative. So you have those two negatives. And then you have plus or minus the square root of -3 squared minus 4 times 1 times -3 all over 2a, which is 2 times 1. So we want to simplify this, and you must use the correct order of operations. So the -3 in front will become a positive, and inside the square root, -3 squared will become 9. And then to find the next part, you're going to take -4 times 1 times -3. Those two negatives will make this a positive, so you'll put a plus in there instead of a minus. And then 4 times 1 times 3 would be 12. So we have 9 plus 12 inside the square root. Okay, but this isn't quite simplified as much as it could be. We still need to add the 9 and 12 to get 21. So at this point, we would want to see if we could simplify the square root. Okay, we don't know the whole number. That would be the square root of 21. And you could try to simplify the square root of 21 using the factor tree, but the only numbers that multiply to 21 are 7 and 3, and you wouldn't have any pairs. So you can't actually simplify the square root of 21. So this whole thing would be your answer. Okay, so let's try a problem where we could simplify the square root. Okay, so in this example, we have 3x squared minus 4x plus 6 equals 0. A is 3, b is -4, and c is 6. So you'll plug those in. It should look like that. And then you'll start to simplify. Okay, the -4 will become a positive. -4 squared is a positive 16. And then we have a -4 times 3 times 6. Okay, there's only one minus sign, or negative sign, so we're going to get minus. 4 times 3 is 12, times 6 would be 72. And once you subtract those, you'll get a -56. Okay, so remember, we want to try to simplify the square root, and this time we actually can. So off to the side of your paper, make a factor tree for 56. You get 7 and 8, and then 2 and 4, and then the 4 can simplify to 2 and 2. Okay, so using all of those, we'll get this. And also remember the negative inside the square root, we want that to be positive, so we'll take out the I out in front, and then we'll also look for pairs inside the square root. So there's a pair of 2's. So the 2 will come out in front of the I, like this. Then you want to multiply the 7 and 2 to get 14. Now, at this point, there's a little bit more that we can do to simplify. If you notice, we have 4 over 6, and then there's also that 2 over 6. We want to simplify those fractions as much as possible. 4 over 6 would become 2 over 3. 2 over 6 would become 1 over 3. So our problem would look like this. Never try to simplify what's inside the square root with the denominator. It doesn't work. Please don't do it. Okay, only the numbers out in front. Okay, so your final answer will be 2 plus or minus I to the square root of 14 over 3. Okay, so for today's problems, you have a mixture of problems that can be factored or solved by factoring, and some of the problems can be solved by using the quadratic formula. I want you to always try to solve by factoring first. If that doesn't work, use the quadratic formula. Okay, the quadratic formula does work for every single problem all the time, but obviously it's time consuming. So I want you to try to solve by factoring first, because if a problem can be solved by factoring, then it'll be a lot quicker, a lot easier, and you're less likely to mess up that way. Okay, I'm pretty sure in your assignment there's about 4 or 5 problems that you will have to use the quadratic formula. The rest of them you can solve by factoring.